Okay, we're on section 1.4, extrema and the average rate of change. And so we're going to be looking at the different parts of the graph of an equation and looking at whether they're increasing, constant, or decreasing. Remember, if we have some kind of graph going, there's a part of the graph where it is increasing. There is another part that it may be constant. And there's a part where it could be decreasing. Now remember, not all graphs have all of these. The graph may be only increasing for its whole distance. It may be just decreasing and increasing. It may be a constant, the entire graph. So we just need to look at them and piece out what's what and where's what is. So if we look at a graph, tell the intervals where the graph is increasing, decreasing, and constant. Okay, and the graph I'm going to throw in here is going to go kind of like this. Okay, so where is our graph increasing? Well, we have an increasing from here to here, which would be -4, -3, -2, -1. So from -4 to -1, it's increasing. Okay. We have decreasing in two locations from -infinity to -4, and it looks like this is at 2. It's not a union this time, it's just comma, new domain, and it's from the domain of 2 to infinity, it's decreasing. And then it was constant from -1 to 2. Okay, and we always show these with parentheses because we're never including that endpoint because that's a point of change, changing of direction. Okay. If we have a curve and our curve goes up and down and up and down, okay? In this case, it doesn't have, well, let's look at the maximums. Let's look at the high points. So we have a maximum here and a maximum here. This maximum is the tallest one possible. The function is going higher, so that is our absolute. absolute max. The smaller one is called a local max. Okay? On the minimum side here, the minimum in both ends is negative infinity. So there is no point that is an absolute minimum because it just keeps going. So our one bottom of the curve, our one trough, is just a local min. Okay? So if you have it going up to infinity, we would never have an absolute max because it's going all the way to infinity. Okay? But those are the discussion of just getting used to the terminology. Local max, local mins are points where the curve changes direction from an increasing to decreasing or from decreasing to increasing. And an absolute is the highest or the lowest point on the curve. Okay? The last thing we need to talk about in section 1.4 is average rate of change. Okay? And it's kind of like slope. Okay? So if we have a graph, let's say we have a quadratic opening down. And we look at a couple of points. Okay? Our first point here is x1, and the value of that point for the y value would be f of x1. The second point, x2, and its output value, f of x2. And so the average rate of change is the same equation as the slope equation when we think about it like that. It is simply y2 minus y1, or f of x2 minus f of x1 over x2 minus x1. So to find the average rate of change, and now we're going to be on problem 2, find the average rate of change of f of x equals negative x cubed plus 3x on the interval. And so the first one I'm going to look at is -2 to -1. Okay? So if that's our interval, -2 to -1, and the function is a negative x cubed plus 3x, this would be x1, this would be x2. So we need f of x for each of those. So f of x1 is f at -2, which is a negative on the outside, -2 on the inside, cubed, plus 3 times a -2. So that gives us -8. The negative cancels out, so it becomes +8. +8 minus 6 gives me a +2. For f of x2, where we have f at -1, we're going to have a negative parentheses, -1 cubed, plus 3 times a negative 1. So negative 1 cubed is negative 1. The negative cancels out, so we're left with a 1, plus a negative 3 is a negative 2. So to plug it into our equation, f of x2 is negative 2 minus f of x1, which is 2, over x2, negative 1, minus a negative 2, and we get negative 4 over a positive 1, which gives us negative 4 as our average rate of change. If we want to look at it over a different area, let's look at B. And this time we're going to do it from 0 to 1. So the first one is x1, the second one is x2. F of x1 is f of 0, which is a negative 0 cubed plus 3 times 0. And since everything has an x in it, that's going to equal out to a 0. F of x2, which is f of 1, means we're going to have a negative 1 cubed plus 3 times 1. Well, 1 cubed is 1, add the negative, so negative 1 plus 3 is plus 2. So our average rate of change is going to be f of x2, 2 minus 0 over 1 minus 0. It's 2 over 1, which is 2. And that's all there is in section 1.4. So only one video this time, and those are talking about the extrema, the absolute and local maxes and mins, and the average rate of change.